Example 1.3 Coulomb's law. Figure 1.3 shows 3 point charges that lie in the xy plane in a vacuum. Calculate the magnitude and direction of the net electrostatic force on Q2. First step is write down all the information given. You have Q1 is negative 6 times 10 power of negative 6 Coulomb. Q2 you have 4 times 10 power of negative 6 Coulomb, and Q3 is negative 5 times 10 power of negative 6 Coulomb. And you have here R21, which is R21 is 20 times 10 power of negative 2 meters. And you have R23, which is 12 times 10 power of negative 2 meters. And don't forget, you must calculate the theta here, which is 90 degree minus 17 degree, and you will get 73 degree. Next step is sketch the forces on Q2. So now I draw the charge Q2, or actually if you don't want to draw it, then you have a point charges there. Okay, one point charge just a bit there, and then you have a positive and negative. Then positive and negative, you will get a attractive force. So label it with F21. Okay, so this is your charge Q2 there, and then this is for Q2 and Q1. Next is Q2 and Q3, also positive and negative. Then you have attractive force where you have F, label it with F23. Now you have two forces there. Next is calculating the magnitude of forces acting on Q2. F21 is KQ2 Q1 over R21 R21 squared. F21 substitute value 9 times 10 power of 9, Q2 4 times 10 power of negative 6, and then Q1 is negative, then you don't have to write down the negative, just take the magnitude 6 times 10 power of negative 6, divide R21 is 20 times 10 power of negative 2 squared. F21 you will get, you calculate it and you will get 5.4 Newton. Next is F23, right? KQ2 Q3 over R23 squared. F23 substitute value. Q2 is 4, negative 6. Q3 is negative 5 microcoulomb. Just take the magnitude 5 times 10 power of negative 6 over or divide by 12 times 10 power of negative 2 squared. So you will get your F23 is, calculate it, you will get 12.5 Newton. This is your second step, and the next step is actually you construct the table. You have here force, and then X component, in Newton, and then y component in also unit in Newton. So now you have here F21, F23. Okay, so F21 in x component, F21 will be cos 73 degree. Okay, where you resolve it into two components, and then you calculate it 5.4 cos 73 degree, and you get 1.58 Newton. While F21 sin 73 degree also positive because it is to the right. So here, if you resolve it, here you will get here is your F21x, then upward is F21y. Okay, so now you have F21 sin 73, which is 5.4 sin 73. So we get 5.16 Newton. And then for your F23, you just have on the x-axis, so it has only x component. Your F23 is, just take the value 12.5 Newton, and your y component of course 0. Then you calculate your total here, summation F. So for Fx, you will get 1.58 plus 12.5, where you will have 14.1 Newton. And then your Fy, here you will get 5.16 plus 0, and Fy will be 5.16 Newton. Next step is you want to find the magnitude. How do you find your magnitude? Then you write down here magnitude. So your magnitude will be F2. So F2 will be Fx squared plus Fy squared. Okay, and then forget to write down. Then square root 14.1 squared plus 5.16 squared. So you will get your F2, which is 15.0 Newton. Okay, this is your magnitude. Then how about your direction? So direction we write down on the right side here, which you actually use theta is tangent inverse Fy over Fx. So your theta will be, substitute your value, tangent inverse Fy 5.16 over 14.1. And you will get your theta is 20.1 degree, which is above positive x-axis. So this is your answer.